Hello all, welcome to the Scripting Wi-Fi Pentesting Tools in Python series at Pentester Academy. Now in this course, we will teach you how to script your own Wi-Fi sniffers, injectors, and even create useful pentesting tools in Python. Now what are the prerequisites for this course? Well, you should at least know the basics of Wi-Fi security and Python scripting. Now, please note, I do not assume that you are actually a master of either or both. My assumption is that you know the very basics of both of these subjects and can write at least very small Python scripts. Now, in case you have not done any of these courses, please use the link and then you can go ahead and go through these courses and then come back to this series. Okay, so let's begin. Now, if you wanted to write your own Wi-Fi sniffers, pretty much tools like Wireshark and aircrack-ng, which can parse packets, store packets in files, what would you need to do? Now, the first approach is really a very low-level approach of using raw sockets. I'll give you some examples at the very end of the course. Now, the problem with raw sockets, of course, is you would have to do a ton of stuff by yourself, including telling your network stack that you need the packets. You would need to create a buffering function so that when the packets come in, you can store them somewhere temporarily before you act on them. There are tons of complexities involved in writing a very good quality Wi-Fi sniffer using the raw sockets approach, right? The other, of course, is the library approach, where we use a library which is a wrapper around these raw sockets and provides us with a lot of additional functionality. Now, such a library is scapy, which is what we will use in our first couple of exercises. So let's move on to scapy basics. Now, what is scapy? Well, if you think about it, scapy is actually a general purpose library to sniff, inject, and parse network packets. Now keep in mind that scapy supports a ton of protocols, one of them being 802.11. Now scapy can run interactively or can be imported as a module into your Python programs. Scapy is written entirely in Python, and you can look at the details here. Now, if you go there, you should also probably find a link to Scapy's documentation. It's a bit old. The documentation hasn't, kind of kept pace with the version of Scapy, but I think this is a good place to begin. Okay, so let's begin, right? No death by PowerPoint as promised. So the first step, of course, is to put your card into monitor mode so that we can use it with scapy. So if I run airmon-ng without any arguments, I see I have a Realtek RTL8187. This is really my alpha card which I have in here. I'm going to set this to monitor mode. Let me first do a check kill, so that we kill any processes which can interfere with our monitor mode. And then let's start WLAN 1 so that we can create a mon0 interface, or our first monitor mode interface. Okay, let's quickly run aircrack-ng to verify everything is working fine. Okay, seems to be working okay. Awesome. So now let's begin with scapy. Now in this first video, we will use scapy entirely in interactive mode. Now here's the good news. If you are going ahead and using Kali Linux, scapy is installed by default on Kali, right? I'm using Kali 108. So let's type in scapy and hit an enter. Okay. Now, if you want to look at the default configuration with which scapy loads, you can type in conf and hit an enter. You would see a bunch of stuff, right? The one which we are interested in is pretty much the iFace or the interface on which scapy is going to work. Now, if you notice, by default, this interface is ETH0, while we are interested more in the wireless traffic. So let's go ahead and do a conf.iface equals mon0. There we go. Now let's actually write our very first sniffer. So let's say, we create a simple variable called Wi-Fi packets to hold the Wi-Fi packets we are going to sniff from the air. And now let's write 200 lines so that we can create a sniffer. Blah, blah, blah. And there you go. You just wrote your very first sniffer in scapy. That's how easy it is. All you have to do is call the sniff function. It takes in a lot of arguments as possibilities. The one which we've used right now is count, which tells sniff the number of packets it needs to capture before returning. Awesome. Now, if you hit Wi-Fi packets without any arguments, without calling any other functions on it, actually find other is set to 1. This is really your Wi-Fi packet. You can very quickly do a summary, and if you notice, we've captured a beacon frame. It clearly says the SSID is Burma House. You could even do interesting stuff on it, such as going ahead and printing the packet out as a PDF using PDF dump. Now this gives you a very beautiful visualization. If you notice, we have small amount of details from the radio tap header, then the .11 header, and then you have the actual beacon header with a lot of information, including different IE elements, right, or information elements. Now, scapy by default might not be able to parse all of these elements. It, however, does give you a couple of them. The most important, of course, is the SSID. That's something it parses successfully. Okay. Now, let's say you want to go ahead and sniff a lot more packets. All you would have to do is change the count and let's say make it to 10. Right? And now we sniff 10 packets. Let's do a quick summary. Okay. Looks like we pretty much got most of them, the same SSID, which seems to be around. So here is what I'm going to do. By default, scapy cannot do any form of channel hopping. So let's go ahead and hop channels using aircrack-ng. Aircrack-ng mon0 should do it. Any of this is confusing, you definitely need to go back and look at the first couple of Wi-Fi security videos, right? The assumption is you know the basics of Wi-Fi security. Okay, let's go ahead and sniff a couple of packets again. Hit the summary. Great. Now we have some variations. We also have a couple of control frames this time and management frames, right? Now, if you notice, summary can get a bit confusing. If you want to go ahead and also write out the actual packet number, you can use n summary, which now gives you the packet numbers as well. Awesome. Now, if you'd like to dump all of these packets in hex, you can actually use hex dump. And this dumps these packets in hex in case you would like to go ahead and, look at the hex dump, see some other interesting aspects of it. Fantastic. So what we've seen, of course, is setting up the interface, sniffing a packet, how to create a PDF, and how to sniff multiple packets. Awesome. So I think this is a great start. In the next video, we will look at packet handler functions and how we can integrate them with scapy. So hope you had fun. Please try this out. And if you have any feedback, tweet to us via SecurityTube on Twitter or write to us on our Facebook fan page. Again, all of which you can find by just clicking on Facebook or Twitter above. Thanks so much, guys. See you in the next video. Bye-bye. Welcome to the scripting Wi-Fi pen testing tools in Python course at Pentester Academy. Now, in the last video, we saw the basics of scapy and how to begin sniffing packets with the sniff function. Now, in this video, we are going to look at packet handlers in scapy. So, what is really a packet handler? Now, in the last video, we had used the sniff call to go ahead and receive Wi-Fi packets using scapy. But what do you do with these packets, right? You might want to analyze them and probably take action, which might include printing out a report, which could be a summary of what you see over the air, or it could be even injecting packets to conduct an attack. There could be a host of things that you would like to do. Now, this is where packet handlers really make things very convenient and allow us to process each packet individually. Typically, these are callback functions, and let me show you how this works. So let me go inside scapy again. I'm going to set the interface to mon0. Now let me actually define a packet handler. So def in Python is for define. Packet handler takes an input which it is going to receive, which is the actual packet. Remember, Python is a language where indentation is important. I'm using 3 spaces right now as indentation. Now within this we can do a print packet.summary and then return. Now we can have our sniff call and sniff, let's say 10 packets. Now let me check if my card is up and running. Oh, my mistake. You're sniffing, but we haven't mentioned the packet handler anywhere. And this is where we're going to set prn, which is where you mention the packet handler. And we point it to the packet handler function. There you go. And if you notice, now we are receiving our different frames, and this would pretty much continue till we receive all the 10 frames. Okay, now how do we do more processing? So for this, let's go ahead and use scapy as a module in Python so that we can do a lot more stuff with it. So I'm going to go ahead and now write a simple Python script. The editor for me is going to be Vim. Feel free to use Pico, Nano, or any other editor you might like. Let me call this packet handler.py. I'm going to take the sys module, simply because I'd like to accept command line arguments in the form of sys.argvx. And then let's import scapy. So here's what we're going to do. We're going to do a from scapy.all import star. Now let's go ahead and define our packet handler function. packet handler, and let's print the summary of the packet and just return. Use the sniff call here, iface equals sys.argv1, the first argument, count equals, let's convert to int, the second argument, and then finally the packet handling function, packet handler, just as we've defined above. Now let's run this with mon 0 and 10. We also start arrow dump so that we can probably see some traffic. And there you go. Right, let me restart this again. Turn off my Wi-Fi. Great, right? So you can see probe request packets and a bunch of other things. For example, my laptop was sending out probe request packets for an SSID I had connected to before. And in this case, we go ahead and see a lot more packets. Now, here is the interesting thing, that if we had run this on eth0, and let me go ahead and ping, so let's figure out the IP address, ping 10.0.2.2. If I do this, if you notice, scapy is now going ahead and printing the ICMP echo requests and responses, right? This is fantastic, but honestly, we need some way by which we can detect that the received packet is actually an 802.11 packet, because that's all we are interested in. So how do we do that? Well, it's really simple. In scapy, we can actually leverage a call called hasLayer, within which you can mention the layer you're interested in. So let's say .11. So what this means is, if this is a .11 packet, then we are going to go ahead and do this. Else, let's just go ahead and print not an 802.11 packet. Right, fantastic. So now if we go back in here, we continue with our pings. You'd see it says not an 802.11 packet. For all the packets it sees on Ethernet. Now when we run it on mon 0, it pretty much goes ahead and gives us only the .11 packets. Right, fantastic. So this is really how you can go ahead and write a very simple packet handler in scapy, and this packet handler now checks that this is really a .11 packet which we have just received. If not, it goes ahead and does nothing, but just prints not a .11 packet, right? So try this out. I think this is probably one of those very important examples where you understand how we can go ahead and look at what is there inside the packet and parse it further. So hopefully you had fun in this video, and if you're enjoying your time at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Welcome to the Scripting Wi-Fi Pen Testing Tools in Python course at Pentester Academy. Now in this video, we will look at understanding layers in scapy. and this is one of the most important concepts you need to go ahead and know. So layers in scapy, well, packets are really subdivided into multiple layers, and every layer basically has a payload which contains all subsequent layers. So to give you an example, a typical 802.11 packet would contain a radio tap layer followed by a .11 layer and then a .11 beacon and .11 ELTs, right, which are information elements. Now, to find out the list of supported layers, you could run scapy and just type in an ls call, and this gives you a huge list of supported layers within scapy. As you can pretty much see, scapy has a lot of stuff to offer well beyond just 802.11, right? And the .11 part is in here. So these are the different layers supported for .11. We can see there are a couple of management frames, some web packet is there available as well. And if when you're going ahead and writing a sniffer or injector, you could use a layer, then definitely please do so, because it would simplify a lot of stuff which you would have to write. Only if a layer is not present, either you can do the parsing yourself or write a new layer for it. Now, similar to layers, if you'd like to look at all possible operations, you could do an LSC and enter, and this would go ahead and give you all operations, right? We've looked at sniff till now. There are other operations as well which we would use from time to time, which you would find with LSC. Now, how do we go ahead and traverse layers? So for that, let's first capture a packet. Let me set my interface to mon0, which is a monitor mode interface which I've already created. And let's go ahead and sniff some packets. Let's say 10 packets. Let's look at a quick summary. So let's pick up, let's say, the very first packet. Let's say pkt is equal pkt as 0. Let's dump pkt. You can clearly see this is a beacon frame, right? You can see it's a beacon frame. We see a beacon frame layer in there. And the SSID seems to be Alex Wi-Fi. Now, when you look at a packet in scapy, really these show the beginning. If you see the little angular bracket in here, up to the pipe shows the first layer, right? So we have a radio tap layer followed by a .11 layer followed by .11 beacon layer, and then a lot of .11 ELT layers, which are information elements, right? Now if you notice, some of the fields are parsed for us. As an example, the information element for SSID gives us the SSID, while some of them aren't parsed at all, in which case their value in hex is mentioned, right? So as a clear example, we see something with ID 45 and the info field is just a series of hex bytes, right? Okay. So this is very important, because if you want, you could parse it further and get meaningful information from that specific value. Great. Now traversing layers. Now as you clearly see, we begin with a radio tap header, which tells us a lot about when the packet was captured, a lot of parameters. Now here is what you can actually do. To look at what is there in the radio tap header, you can do a ls and then put in radio tap, And if you notice, this gives you a couple of fields: the version, pad, length, present, not decoded. Similarly, you could go into .11, and this would give you the different fields available in this layer, such as subtype, type, the protocol field, right? And scapy has its own internal data structure to represent it: bit field, bit enum field, etc. And pretty much you could go on with this to understand what each of these layers is actually parsing in the packet, right? And then finally you have .11 ELTs, which are basically type length value pairs, right? This is the type, for which is ID, this is the length, and this is the actual value. Now for any given packet, let's say LSPKT would go ahead and parse all of these fields and give it to us so that we can analyze it. So to give an example, we've done an ls over packet, and now if you notice, it gives us actual values inside the packet, right? If you recall, this was the radio tab header followed by the 802.11 header, right? We can clearly see this is the beacon frame layer. I actually prefer to call it layer rather than header. And then after that, all of these triplets together are information elements of type length value, right? So for type 0 or ID 0 is really the SSID. ID 3 is basically the channel, right? We can see it's actually on channel 1. And depending on the ID, you can go ahead, look at the standard and see which values are interesting for you. So if you notice, pretty much using scapy, we can now get an idea of what we can extract from the packet. Now, let's go ahead and traverse layers, right? So PKT currently begins with the radio tap layer. Now, as I mentioned, for the radio tap layer, all subsequent layers, or rather the .11 layer and all of the .11's payload inside, pretty much is what it encapsulates logically, right? So if we actually do a pkt pkt dot payload, we would get the next layer and everything after that till the end of the packet. So we would get .11 and forward. There you go, right? Now if we actually want to move forward, we can do a dot payload again, and for the .11 layer, this basically means everything, right, inside of it, which is the .11 beacon layer followed by everything inside. Now at this point, of course, pkt.payload.payload would give us the .11 beacon layer as expected. And now for this, all of this would really be the payload, right? So I could go ahead, write a dot payload, and now we have the very first .11 ELT, and honestly we could just continue indefinitely moving forward, right? So the first .11 ELT was the SSID, and of course its payload is going to be all of this in here, and that's why the dot payload gives us everything beginning at ID equal rates, as you can clearly see here, right? Fantastic. Now if you want to move back, all you have to do is under layer. So dot under layer, that actually gives you the parent layer. So if you notice, now we are back with SSID, and if I do an under layer again, this goes back again to give us the .11 beacon, and if I go back and put in another under layer, and this gives me the .11 layer, and finally dot under layer would give me beginning from the radio tap layer. right? So this is how we can travel back and forth. Now, for a given packet, if you wanted to just print out all the different layers, the approach is really very simple. Here is our packet, right? Let's go ahead and assign the packet to temp so that we can keep moving temp from one layer to a subsequent layer and kind of move it forward till we reach the end of all layers. And I can actually do a while temp print temp.name. This actually prints the name of the layer, and then temp is equals temp.payload. As you can imagine, we are progressing forward so that the next time we move on to the next layer. And there you go. This gives us the output. We have the radio tap layer, the 802.11 layer, the 802.11 beacon, and a bunch of information elements. Fantastic, right? Awesome. So this is how we can traverse through layers, look at different fields in the layers. So as an example, if I wanted to look at the .11 ELT, one of the ways I could actually do this is, let's actually look at the packet here once again. So we have packet.payload, which progresses me to the .11 layer, followed by another payload which progresses to the .11 beacon layer, followed by the next one which takes me to the very first ELT, which is this one, which seems to be SSID. And if I wanted to go ahead and get the info field, I could do just a .info. And there you go, we've extracted the SSID, right? Fantastic. Now, of course, there are other ways to traverse and access layers as well, one of which is get layer. So let's say if I wanted to get the .11 beacon layer, could actually do, let's say, beacon layer equals pkt dot get layer .11 beacon, right? So this would actually go ahead and give me the .11 beacon layer, and of course, the payload inside of it as well. And now using the beacon layer, I can go ahead and print out stuff of interest to me. Maybe as an example, the beacon interval. Which is 100, right? At the very same time, you can even check for layers in a given packet. So let's say we'd like to check packet.has layer is what allows us to check if a layer is present or not. And in this case, let's just check for ARP. And if you notice, well, it doesn't look like ARP is there. .11, and if you notice, it gives us a 1, which is basically is present. Fantastic. So hopefully in this video, the concept of layers in scapy, payloads, under layers, how to traverse different layers, check for layers with has layer, as well as get to a specific layer using get layer is clear to you. These are very important concepts you need to keep in mind while using scapy, and these can actually make your life very, very simple when you write parsing code. Okay, thanks guys. And if you're enjoying your time at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Welcome to the Scripting Wi-Fi Pentesting Tools in Python series at Pentester Academy. Now in this video, let's create a simple Python script with which we can find all the Wi-Fi devices around. Now, how would we plan to go ahead and do this? Now, if you recall from the Wi-Fi security basics, series, that address to in the WLAN header is the transmitter address. And if we create a unique set of all transmitter addresses around, then we get a set of all unique Wi-Fi devices around, right? So let's jump right in. I'm going to call this script all devices.py. First step, of course, is to put in the imports, import sys, and then from scapy.all, import star. Then we have our sniff call. The first argument, of course, is the interface. Let's take this as user input, sys.argv1. The second argument is the count, the number of packets to go through. Again, let's go ahead and take this as user input as argv2. And finally, the third is the callback function or the packet handler routine. Let's call this packet handler, right? Now let's define our packet handler here. It receives the packet as input. Now, the first step, of course, is to ensure that this is actually a .11 packet, right? So we can do that by checking if pkt has layer .11, and if that is the case, then let's go ahead and get the .11 layer, right? Now there are some shortcuts available which we will discuss a little later. In this case, we will go through the long and hard technique, right? So I'm going to say .11 layer equals pkt dot get layer .11, right? Now let's also define a set which can hold all the MAC addresses of the Wi-Fi devices we are about to discover. Let's call that set devices. Now, here is what we're going to check, right? If .11 underscore layer dot addr2 to begin with exists, and you also need to ensure that this address right is not in our set of unique devices, right? Not in devices. Then let's go ahead and add this. So we have devices.add .11 underscore layer .addr2, and let's go ahead and print this address. Right, that's it. This should give us the list of all unique devices around. So I hope there aren't any typos. We'll know in just a bit. All devices. On 0, 100,000. Let's go ahead and also run aerodump-ng so that it cycles around. So I'm just done an aerodump-ng mon 0, and as you can clearly see, we are starting to get the list of all unique MAC addresses around. Fantastic, right? Let's go ahead and put in a number as well for every MAC, just so that we can quickly figure out how many unique devices we've discovered. This should be easy. Just a quick len on devices should give this to us. Right, and now we can quickly see the list of unique Wi-Fi devices around. Now, one of the other interesting things we could check is what packet or really what type of management control or data frame uh, is going ahead and telling us that this is a new MAC, right? So to add that, again, it should be very simple, and this actually derives on what we learned in the last video regarding the payloads. We could just say, hey, .11 underscore layer, the payload, which would actually give us basically the kind of packet dot name, right? Of course, this is limited to the kind of packet scapy supports. So let's go ahead, hit this. Now this is a little bit more exciting, right? So if you notice, we are now getting the packet number, a unique Wi-Fi MAC address, and at the very same time, the actual packet from which this MAC address was ripped, right? Fantastic. So you can clearly see with just a few lines of scapy how we were able to go ahead and create this. Now, let me also discuss some shortcuts. Let's copy this to all devices v2. Now let me open up all devices v2.py, right? Now, a couple of shortcuts do exist which you can use if you want, which is just with packet. If you recall, we did an ls over pkt and it gave us the different fields and what were available. So you could actually do an if pkt.addr2, right, and pkt.addr2 not in devices, devices.add pkt.addr2 print len devices pkt.addr2. Right? Now this is a quick shortcut by which we can access the MAC address. Fantastic. So now you have both versions. Personally, I think in the learning phase, I would really recommend using the whole get layer and all of that, because that ensures that it follows a very logical flow rather than using any quick shortcuts. And I would highly recommend using that technique. Fantastic. So that's all, guys, for this video. Hopefully you enjoyed it, and if you have, please do recommend Pentester Academy to your friends and colleagues in the InfoSec community. Thank you. Welcome to the Scripting Wi-Fi Pentesting Tools in Python series at Pentester Academy. Now in this video, we're going to make a little bit of more progress and create our own SSID finder using scapy. So how do we do that? Well, very simply, just two steps. Step 1, filter based on beacon frames, and step 2, iterate through all the tagged parameters and find the SSID. So let's jump right in. Now, the first thing we're going to do is actually launch Wireshark this time. I already have Mon0 created on monitor mode, so ensure you do that. And let me pick up a beacon frame here. Let's look at it for just a bit. So if you notice, we have tagged parameters, and here is the SSID parameter called Khan. And the first thing which probably you might see here is that there are a bunch of tagged parameters, right? and the SSID has a tag number set to 0. This is important because this is type length value. Interesting. There are also other tagged parameters which are there, right? As an example, you have the channel set in a tag number 3, right? You have supported rates, you have a bunch of other things. Now, typically, the SSID would be the first tagged parameter. However, of course, a vendor could rearrange them. You're supposed to pass through the tag length value rather than assume that the SSID would always be the first. But most APs have the SSID as the first one, and hence I've seen a lot of scripts using scapy and raw sockets which make the same assumption, right? So here is what I'm going to do. The first version of the script is basically going to go ahead and have the assumption that the SSID parameter is the first tagged parameter, right? And then after that, in the second version of the script, we will iterate through all the tagged parameters, or IE or information elements as they're called, and find the SSID. Okay, so let's jump right in. Now let's call this script SSID finder.py. Let's import whatever is required. And ideally, guys, you should be typing in along with me, right? That just ensures that, you are trying it out as well, right? Please don't take my code and just run it, right? It won't serve a purpose. If that's all you wanted to do, I think aircrack-ng suite of tools is way better than probably what we can write in scapy, or at least with, so little of scapy. Import scapy.all. Right, then let's go ahead and define our packet handler. Let's define our sniff here. Number of packets to sniff, and finally the packet handler. Great. Now the first step, of course, is we'll have to check if this is a beacon frame or not. That should be simple. If packet.has layer, right, .11 beacon. And if you're wondering where I got that, if you recall, when you were playing with scapy, you did an ls, and at the very top in here, we actually had a .11 beacon layer already defined for us, right? And that's how we can quickly check that. Then in this case, let's use the shortcuts. We'll just do a print. Let's actually define our SSID set as well. And let's actually do a quick check first. If pkt.info not in SSIDs. Right. Print len SSIDs, which basically gives us the number of APs we are seeing. Now pkt.info, if you recall, would contain the SSID, right? This is of course assuming that the first ELT is going to be the SSID. Then let's print the MAC address. pkd.addr3 should be the BSSID. pkt.info. may have forgotten to do an add. So let's do ssid.add so that we add it to our set, and the next time we don't end up printing a duplicate. pkt.info. Just let's also ensure that pkt.info exists. And there you go. We have our SSID sniffer, right? The reason it's starting with 0 is we should have done the add before we did the print. This should solve it. And there you go, right? We have our SSID sniffer. You can run aircrack-ng. Remember, currently there is no channel hopping which can happen by default. We'll look at how to write your own channel hopper in scapy a bit later. But yeah, you can go ahead, hop channels, and that way the SSID sniffer would go ahead and find new SSIDs. Great. Now this was version 1, and as I said in this, our assumption of course was that the first ELT pretty much contained the SSID. Now let's go ahead and go through a more iterative approach. Let's call this SSID finder v2.py. Let me open up v2 now. Let me remove this part. Let's actually very quickly just look at a beacon frame within scapy, right? So let's do this. Packets equals sniff, iphase equals mon0, count equals 10. Okay, so here is a beacon frame at number 9 as an example. We'll just take that. Yes, 9. Right? So now what we said is, in the very first version, we assumed that after the .11 beacon layer, we have our .11 ELT layers begin, and the very first one was assumed to be the SSID, which is typically the case. Now, what if we had to iterate through all of these .11 ELTs and find the SSID by using the ID value, right? The ID value for an SSID is 0, just as what we saw in Wireshark, right? Here it is. So you can pick up a beacon and verify this, that the tag number is actually 0. Okay, so for this, we would go ahead and iterate through all the .11 ELTs. So let's do that. Now at this point, what we have to do is basically find .11 ELTs, right? So let's actually use a temp variable. Now we do a while temp equal to temp dot get layer. Let's actually get the .11 ELT, right? And at this point, right, here is what we can do. If temp and temp.id equals 0, right? This is the first step. And temp.info, right? If you recall, the info was what was containing the SSID, and temp.info, not in SSIDs, right? This is going to be our SSID list. Let's actually define that as a set here. It's already defined. Great, up here. Now, if this is the case, then we found ourselves a brand new SSID. And what we're going to do, of course, is add it to our set. So SSIDs.add temp.info. And we could even go ahead and print stuff in here. Print len SSIDs. We could print the MAC address, pkt.addr3. Then finally the actual SSID, which is temp.info, right? And then at this point we can break, because there is no point iterating through any more .11 ELTs, right? There's only going to be one containing the SSID. And here, let's say in the very first iteration we did not find the SSID tagged parameter, then we need to continue our search, and that's why I'm going to use temp equals temp.payload, so that we can move on to the very next layer and then go back and search if there are any .11 ELTs in there, right? This looks okay to me. Let's check if this works. SSID finder v2.py mon0. Okay, perfect, seems to be working great. Right, now what was the best thing about the code snippet I just shared with you, right? The best thing was that we are iterating through all the ELTs, which means you could actually have iterated and checked for anything else as well, which includes, let's say, the DS parameter, the supported rates, and even later on stuff like RSN information, which would tell you that if it's a WPA2 AP, or what is it really doing, what are many other capabilities that the access point can have, right? And this is the trick here. All we have to do is keep changing temp.id, and depending on the ID, temp.info, what it would contain and how to interpret it. Now, as I mentioned earlier, a lot of times scapy might not go ahead and interpret and parse the actual info inside an ELT, in which case you would have to do it yourself, right? Fantastic. So hope you guys had fun, but keep in mind there's one small thing here. In this case, I'm just finding one AP with the SSID. If there are multiple APs advertising the same SSID, we might just find one of those APB SSIDs here, right? One of the things you can try is how you can maintain a list of BSSIDs for a given SSID, right? And maybe print them in a comma separated way, right? I leave that exercise to you. So hopefully this video was fun, and if you're enjoying your time at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Welcome to the Scripting Wi-Fi Pentesting Tools in Python series at Pentester Academy. Now in this video, we will look at how to go ahead and search for client probes in the air with scapy. Now, why are client probes important? So if you go back to the Wi-Fi security videos, what you would probably figure is that this is the very first step in attacking the client. That is figuring out the networks the clients are probing for, and then creating honeypots with the same SSIDs. Now it is important, however, to note that every client might probe for multiple SSIDs. Hence, just like in previous cases, unfortunately, we cannot use the client MAC and go ahead and use that as a unique criteria. So let's go ahead and actually write the code. I'm going to call this clients.py, client probes.py. Let's import sys. Let's import scapy. Let's call this client probes and make this a set. Let's define our packet handler, which gets a packet as input. And let's sniff the air. Great. Now the very first test, of course, is to ensure that this is an actual probe request packet. So let's open up Wireshark, quickly look at how probe request packets look like. So let me enable my Wi-Fi as well. We seem to be getting a ton of probe requests, as you can see. Let me just select one of them. Let's say Novotel, right? Now, if you notice, there are a bunch of tagged parameters, and the SSID in this case is a tagged parameter similar to what we saw in beacon frames, right? Cool. Let's go back. Let's actually run scapy and figure out the layer associated with probe requests. This seems to be .11 probe request. Let's copy that. Go back. Now let's start writing our handler. Don't need the return. If packet has layer .11 probe request. Now in this case, let's try and use some of the shortcuts, right? Now if we go back to Wireshark, address 2 is pretty much going to be the transmitter address or the MAC address of the client. And as the SSID is the very first tagged parameter, the info would go ahead and give us the SSID. So let's do the following. If length of pkt.info, it's basically the length of the SSID, is greater than 0, we don't want null probe SSIDs, so we are removing that. Then now we have to go ahead and put in unique client SSID pairs, right? Because as we've seen, a client can send out probe requests for multiple SSIDs. At the very same time, we do not want that we end up showing the same client SSID pair again and again. So let's actually prepare a test case, and basically what this would be is just a simple concatenation of pkt.addr2 plus, let's say, 3 hyphens pkt.info. This should actually be the SSID the client is probing for. Now let's check if this is inside the client probe set, right? If test case not in client probes, Just create client probes.add test case, right? And let's also go ahead and print this new probe found. And let's concatenate pkt.attr to pkt.info. Let's see if there are any bugs. Okay, seems to be working fine. I think we just need a little spacing in there between both of these. Here is one small mistake. I think we're good. Test case is not there. Okay, looks good. So let's patiently wait for a couple of probes. Quickly generate them by searching for networks. This is our client, and these are different networks it seems to be searching for. Now, maybe we also want a very simple table to be printed as well. And that table is created from our client probe set. So here is what we can do. Every time we add something new, let's also print the table. Client probes table. Little bit of simple ASCII art in between. And here is what we're going to do. Let's go ahead and iterate through the entire set. So for probe in client probes, client comma SSID equals probe dot split. I'm going to use the 3 hyphens in here. There we go. Print client SSID. Right, we can even have a little counter in here. Counter equals we'll just have a counter equals 1 in here. And just increment the counter. Okay, seems good. So if you notice, there's one client added and a bunch of them were added in here right now. Fantastic. Right, if I kill this and go up, you would notice that every single time a new probe was found, the table was updated. We see one additional client here searching for this network as well, but now we have a beautiful little table, and if you notice, we've actually found 16 different SSIDs for which clients are probing around. Fantastic. So you're slowly observing that just with a couple of lines of Python, how much power you have in doing custom jobs. I'm hoping you enjoyed this video, and if you have, please do recommend Pentester Academy to your friends and colleagues in the InfoSec community. Thank you. Welcome to the Scripting Wi-Fi Pen Testing Tools in Python series at Pentester Academy. Now in this video, we will look at how to uncover hidden SSIDs using scapy. So what is a hidden SSID? Well, the administrator has decided that the SSID should not be broadcasted in the beacon frames. And as we've seen in the Wi-Fi security videos, the SSID tagged parameter still remains, but the length is 0. So how would we find hidden SSID networks? Very simple. We would go through beacon frames and single out those access points which have basically the SSID set to null or no SSID. How do we uncover hidden SSIDs? Again, going through the security basics course on wireless, all we would have to do is monitor probe responses from the same access point, and probe responses contain the SSID, which we can then uncover. So let's go ahead and write a script to do this for us. Let's call it uncover hidden SSIDs.py. Port socket. Import scapy. Let's define our hidden SSID AP set, which we can maintain in case there are a large set of hidden SSIDs. Hidden SSID APs. Now let's go ahead and write our sniff call. Count of packets to sniff. And then finally the packet handler. So let's now define our packet handler here. Now the important thing is we are looking for beacon frames to find hidden SSIDs. So if pkt has layer dot 11 beacon, then we are in business. And in this case, the SSID, which is contained in packet.info, as we've seen in previous videos, should not exist pretty much. So if not packet.info, and then we check if we already have this access points BSSID in our list. So we have if not, or let's do this way, if pkt.addr3, which is the BSSID, not in hidden SSID APs, then let's add it. Hidden SSID APs dot add pkt.addr3, and then let's announce we found a hidden SSID network. Print hidden SSID network found BSSID, and then we have the BSSID, which is pkt.attdr3. Let's first test this code. Now I already have a hidden SSID network AP set on channel 8. See that here. So let's run this, and if you notice, it immediately said it's found at least one hidden SSID network. There are others as well. This is the one I'm interested in. This is the one at least I've set up. Seems like there are a couple of them. Great. Now, here is what we're going to do. Go back. Now let's write the hidden SSID uncover part. pkt has layer. And this time we are looking for a .11 probe response. Right. Now, most importantly, first of all, the address should be in our hidden SSID set, right? So we have if t.attdr3 in hidden SSID APs right? This is what we are really looking for. You could even go ahead and have both of these as part of the same condition. Then print hidden SSID uncovered PSS hidden SSID uncovered, and then we basically have pkt.info pkt.attdr3. I think this should do the trick. Okay. So we're finding a bunch of hidden SSID networks here. Now, actually turn this off. Let me restart this. Join another network. Oh, I remember. I've forgotten myself what I said, but I think it was I am secret. The number of packets by then got over. It's actually set a large number. Quick demo fail. Let me just quickly check the hidden SSID which I actually set for this network so that we can connect to it. I'm just pausing the video for a quick second. Okay, so let me now connect to the hidden SSID network. This is a legitimate client. And there you go, right? We managed to connect to the hidden SSID network, and our hidden SSID uncovering tool has uncovered the SSID, which is, this is secret. Fantastic. So you can clearly see how with just very few lines of scapy, now you're actually solving pretty involved problems, right? This includes both detection of hidden SSID as well as uncovering, right? Awesome. So hope you guys enjoyed this video, and if you have, please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all, welcome to the Scripting Wi-Fi Pentesting Tools in Python course at Pentester Academy. Now in this video we are going to look at something very interesting, and this includes packet injection using scapy. And the attack we are going to try is a dictionary attack against hidden SSIDs. Now what do I mean by this? Well, in the last video, you saw that we patiently waited for a probe response packet from the AP to an authorized client, and then we uncovered the hidden SSID. But what if there are no clients around? What would you do then? Now, of course, there is no absolute 100% works always solution, but what one could at least try is take a list of commonly found SSIDs and send probe requests for each of those. And if the access point has one of the SSIDs in that list, then it would respond back and we would uncover it. Fantastic. So how would this work? Well, we would first have to create a list of SSIDs and then a program which sends out probe requests for each of these SSIDs. And the probe request for which the AP responds, if at all it responds, is the one would contain the SSID of the AP. So let's jump right in. So let me call this hidden SSID dictionary.py, and let's go ahead, import sys, let's import scapy, now the first thing of course is to have a dictionary. So I've created a very small one called SSID list, and this is secret. If you recall from the last video, is the hidden SSID network I have around on channel 8, right? This is that network. So I already have the list. So here is what I'm going to do. I'm going to go ahead and send out a probe request for every single word in that list. So let's go ahead and loop through this for SSID in open. Let's take the word list as an input, argv1 for reading. .read lines would give us all the lines. Remember, this contains a trailing /n which we would strip later on. And for each of these SSIDs, now let's create a probe request packet. So packet equals, now we will use the layered approach in scapy. So if you recall, the very first layer is the radio tap header. Now, unless there is something you need to change in a header, we would pretty much allow scapy to do its magic and put in whatever default values it likes to. So there is nothing we'd like to do with the radio tap header. The next header, as one can imagine, is the .11 header. Now, of course, here we would have to put in the type, which for a probe request packet is 0, as it's a management packet, and then a subtype, which would be 4 for a probe request. Let's also go ahead and define some addresses here. My MAC, let's say this is our MAC address. Well, we'll put in a fictitious address. And let's call this BRD MAC for broadcast MAC. It's basically all FFs, so that we can use this in the program down below. Now, ADDR1 is the destination MAC. In the case of a probe request, this is going to be, as one can imagine, the broadcast MAC. Actually, why don't we go ahead and open up Wireshark, take a probe request and analyze that. so that it is very, very clear to you guys. So we're sniffing. We go ahead and put a WLAN. I should have one of the filters in here. This is one for the probe request. Fantastic. Let's go down. Let's look at the probe request. And if you notice, the very first MAC is the destination MAC, which is all Fs. The source MAC, of course, is the MAC address of the client. And the BSSID again is the broadcast MAC. So armed with this knowledge, ADDR1, ADDR2, which is my MAC. Finally, ADDR3 again is the broadcast MAC. Right, so pretty much this is what we would require in the case of the .11 header. After this, we would want to go ahead and put in the .11 probe request layer. Right. In the case of probe request, if you pretty much recall, there isn't much for us to modify. We'll allow to go with the default values. And then after that, we need to put in the .11 ELTs, right? If we go back in here and look at the probe request, you'd actually find tagged parameters. There are many of them. The ones probably which we definitely would need to put in as an example would be the SSID parameter, the supported rates parameter, right? And at the very same time, let's pick up other MAC as well. A DS parameter is something which is also preferred, right? I've seen a lot of APs not respond if this is not set. Just something I've observed empirically. You can try by putting more or putting less and seeing what works for you, right? But we'll go with the safe list. So I'm going to populate the SSID, the supported rates, and the DS param. Now, if you recall, the SSID had a tag number 0. So the first .11 ELT is the SSID. The ID would be 0, and info would pretty much be the SSID, which we picked up from the file. We just ensure that we strip this trailing /n. Now the second one is going to be the supported rates, right? Here is the supported rates. The tag number is 1. And the info parameter, we're going to put these in hex. Let's take these value 24B16. Okay. 24B16. Right, and we need to remember that this is a new layer. And then finally, let's put in the DS parameter. This has a tag number 3 and the value where currently the client would be, which is 8. So let's put it there. ID equals 3, info equals 0x08. Okay, this pretty much looks complete right now. Now let's send this packet out. For this, we're going to use send P. And if you recall in scapy, when we actually did an LSC, send P allows us to send packets at layer 2. Which is really what we want here, right? We do not want scapy to try and figure out where to route it, etc. Send P packet, need to mention the interface, which would be mon0. Now the count is the total number of times you'd like to send the packet, let's say 3, and inter packet time, let's say 0.3. Okay, let's just quickly test the script first. chmod +x hidden ssid dictionary.py, right? And the input is the file which we created, ssid list. Let's see if this crashes or if anything happens. Okay, looks fine. One of the things we could probably add is the SSID we are trying right now before the sendp goes to work. So print trying SSID. Right, let's actually make this a bit more readable. Okay, this seems fine now. So let's go ahead and use the program which we created in the last video, which was uncover hidden SSIDs. And if you notice, it's already sees a couple of hidden SSID networks. Right, let's see which one of these we can uncover. So I'm going to send this out. Default, nothing yet. Security tube demo, this is secret, and there we go. Right, fantastic. So we have the hidden SSID network now uncovered. We could verify this by actually creating a filter for probe responses, right, or really just over the MAC address wlan.addr equals right, and go back in here, send these out, start seeing a bunch of probe requests. If you notice, right, for default first, for D-Link, then Vivek, security tube, and when we send this is a secret, immediately we get a response from D-Link, right? If you're seeing two, if you notice, the second one is actually a retry, right? And there you go, right? We've managed to go ahead and uncover the hidden SSID using a very simple scapy script, right? So you're right now seeing the power which is in your hands if you can just script a bit. Honestly, these are really small programs. If you've understood the layers properly and the fact that you can tweak them, well, sending out packets is as simple as the way we did parsing of the packets. So hope you guys enjoyed this video, and if you have, please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all. Welcome to the Scripting Wi-Fi Pentesting Tools in Python series at Pentester Academy. Now, in the last videos, we looked at how to uncover hidden SSIDs. Right? The first one was a passive technique to search for probe responses, and the second was to use a dictionary-based attack on hidden SSIDs. Now, the question arises, is it possible to use scapy to actually make hidden SSID detection more difficult or even beat it? So in this video, we are going to look at, creating a hidden SSID cloaker or something which might actually make hidden SSID detection more difficult. Now, what is going to be the principle behind this tool? Well, most attack tools, unfortunately, only look at probe response packets from the access point of a hidden SSID network, and based on the SSID they see inside of it, they decloak the network. Now, keep in mind, real-world clients don't care about probe responses unless it's not directed to them. Now, as we saw in the last video, probe requests were easy to spoof, and so are probe responses. So let's go ahead and build our hidden SSID cloaker. So I'm going to go ahead and take the script in the last video, the hidden SSID dictionary.py, and I'm going to save it as cloak SSID because we'll use it as template code. Oops. I'm going to copy this out. Now let's modify cloak SSID.py. Now this is the dictionary, the hidden SSID attack one which we saw the last time. Let's go ahead and make some really quick modifications. I don't need this part. Now we would need to send a probe response on behalf of the access point, which is sending out hidden SSID beacons, which is really the SSID field is all null, and put in some spurious value in there. So let me go ahead. The subtype for a probe response is 5, so I'll change that. Now in a probe response, the destination address is of course a client, right? So I'm going to change address 1 to my MAC, which basically is of some hypothetical client. Now address 2 and address 3 is really the access point's MAC address. So let's take this as input, sys.argv1. Can go back in here, and address 3 also becomes sys.argv1. The next layer of course is going to change from a probe request to a probe response, and the info field would contain this spurious little SSID, which we'd like to insert. Let's say cloaked, right? Could be interesting. And we are going to go ahead and keep the rates and the channel and all of that same, doesn't matter. And this time around, let's actually configure the number of packets as input as well. Let's take that as input, sys.argv2. Pretty much you would want to have this tool run in the background all the time if you want to cloak a production network. Okay, this looks great. Now to actually test this, I have 2 cards on my system. Let me put both of them on monitor mode. Start WLAN 1. I'm going to use one card to send out the probe responses and the other to monitor the traffic, right? That way I know trying to send too many packets isn't interfering with my receiving part. WLAN 2. So I have mon0 and mon1. Let me real quick just run aerodump-ng and ensure that both the interfaces are working just fine. Okay, looks like mon0 requires a reset and so does mon. Okay, mon1 seems okay. I've had some problems with my card lately. Okay, let me just pause this. Okay, we are back. Now mon0, mon1, both of them work. I'm going to monitor the hidden SSID network with aerodump-ng, and I have created the network on channel 8. Now you can clearly see we are monitoring the hidden SSID network, and the interface I'm using for this is mon1, so I'm going to use mon0 to send out our attack traffic. Now the first thing of course is we need to be on the same channel as the access point. So iwconfig mon0 channel 8. You could use the iw set of commands as well. Now cloak SSID basically requires the MAC address of the access point as input, right? And the count of packets to send. So here we have cloak SSID. The MAC address of the AP can be picked up from here. If you notice right now, aircrack-ng shows a length 0. Let's paste this. Let's actually put in 1,000 packets in here. So the packets are being sent. And if you notice, right now the SSID is actually detected as cloaked. Right? Fantastic. Now let me pull up our own little detection tool as well. I'll pause the video. So if you recall, we created a tool called Uncover Hidden SSIDs. And in this case, we gave the interface as input, the count of packets to look in for. So I'm going to have uncover hidden SSIDs.py. The interface would be mon0. Let's put in a large number of packets. And if you notice, we have it detecting the hidden SSID network. Let's restart aircrack-ng again. And now let's run our attack tool. Let's kill it. There you go. This is cloaked. And if you notice, even our tool ends up detecting that the SSID is actually cloaked, right? Funny enough. So you can well imagine you could even create your own little dedicated IDS system which goes on and keeps sending out these packets to confuse tools around, right? Might not be a very scalable approach, but it's fun to see that it actually works, right? Fantastic. So in this video, you saw how easy it is to create a very simple attack tool which can confuse hackers around. Hope you guys enjoyed this video, and if you're having fun at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Welcome to the Scripting Wi-Fi Pentesting Tools in Python series at Pentester Academy. Now in this video, we will look at how to take all of this analysis we are getting from the air with scapy and put it into a database for further analysis. Now, why is this important? So if you've seen what we've done for the last couple of videos, we've made these interesting scripts which can tell us a lot about Wi-Fi clients and access points around. But the moment you kill the script, the only way to retain all of that data is to save it in a text file and then painfully have to go through it every single time you'd like to revisit that analysis. Now, as you can well imagine, this is okay if all you're doing is writing proof of concepts, but if you're on a pen test or doing anything serious, post-analysis with just text data is extremely difficult. Now this is where what if with just a little bit of code we could insert all of this into a database and make it searchable. Now of course you have a choice of using heavy duty databases like MySQL, PostgreSQL and all of that. Personally I prefer SQLite for this specific exercise is simply because SQLite database files are self-contained, which can pretty much be shipped to the mothership where people can analyze it better, look at what is happening, more correlation, etc. While a MySQL or a PostgreSQL database would require a lot of export and recreation on the other side. So check out SQLite. I'm just going to show you the most simple usage of SQLite using Python. Feel free to Google, go to SQLite site and look at a ton of tutorials and sample code. So let's jump right in. Now here is what I'm going to do. If you recall, we created a Python script called clientprobes.py, right? Now what did client probes do? Well, it searched the air, and every single time a client sent out a probe request, it went ahead and told us about it. So let me just run this real quick. just to jog everybody's memory. So here it is. Let me go ahead and start searching. And as you can clearly see, there was a ton of data which is now mined. Now, what if I'd actually like to put this into a SQLite database and tag it with the location of the place? So let's say, collected this at home, at office, at the airport, uh, at DEF CON. So adding another additional column, which would be a human-friendly location tagging, and then all of this into a database so that I can search it later on. So step one is really to create the SQLite database and the tables which will hold all of this information. So let's do that. I'm using Kali version 108. So SQLite is already installed, and the Python module for SQLite is SQLite 3, which we will look at in just a bit. So the first step, of course, is to create the SQLite database, right? So let me call this probes.db, and we use SQLite 3, which is the utility to go ahead and work with SQLite databases. Hit an enter, and now I'm going to create a table. So we have create table. Let me call this clients, open a bracket. Now the first thing we required was actually a row number. Now I would want that this should be automatically created for every entry and auto incremented. Now in databases, as most of you who've ever created a database table know, this should be trivial to do, and it is in the case of SQLite. So let's say we call the row number ID, the row name ID, the column name ID, and we go ahead and definitely make this unique. So we say ID integer, let's make this the primary key, and then let's actually have it auto increment. So we have auto increment. Now the next column is going to be the location, right? So let me actually call this location. Now I'm going to make this a char of size 100, and of course this cannot be null. After this, let me actually create a column for the MAC address. Now keep in mind, in this case I'm actually storing every single MAC along with the SSID, right? Which means for the same MAC there are going to be multiple rows. You can of course play around later and have a more compact database schema, but for illustration purposes I'd like to keep it simple, even though some of the data being stored inside may be a bit redundant, right? So MAC ADDR, let's actually make this char 50 as well. Again, cannot be a null. And then finally we have the probed SSID. So let's call this probed SSID, and this can be pretty long, so let's actually set this to text, not null. And there you go. Now if I do a dot tables, I actually find clients. If you do a dot schema, you actually find the schema used to create clients. Fantastic. Now we can exit SQLite by hitting Control D. Just remember the name of the file, probes.db, right? Now here's what I'm going to do. I'm going to copy client probes into client db.py, client-db.py. So using this as the template, we are now going to add the ability to go ahead and store this into a SQLite database. Okay, so the first thing of course is to open the SQLite database. Now this is very, very simple, right? First, of course, you need the module in Python to work with SQLite, which is SQLite 3. On Kali Linux, this comes pre-installed, right? If not, you can install it. So let's say connection equals SQLite3 dot connect. All we have to do is give the file name. Let's take it as input sys.argv3. And of course, after all the sniffing and storage is over, we would like to close the connection. So connection.close, right here we go. Now, every single time a new client SSID pair is discovered, we would want to go ahead and store this in the database, right? So at this point, we'd like to call the database storage code. Let's say insert in DB. And of course, this is going to be the client MAC and the client SSID, right? So let's go ahead and do this. So I'm going to go ahead and say put in, I'm just thinking if I need to put, I'm just looking at the code real quick just to remind me of what I had really done in there. Okay, so I'm just going to put in pkt.addr2 along with pkt.info, right? And I'm going to go up here and define insert in DB MAC SSID. I got the name right. Yes, insert in DB MAC and SSID. Now this should be very, very simple right now. So we're just going to do a connection dot execute, and then we are going to put in our query here. Now if you recall databases 101, right, this is as simple as insert into clients, right? And let me quickly remind myself of the different the different column names. Location MAC ADDR probed SSID. Okay. Location MAC ADDR probed SSID. Values. Again, let's make this parameterized. And then let's feed in the values. So first is location. Let's also take this as input. So sys.argv4 is what we pass in as the current location along with the MAC and the SSID. There we go. After this, we need to commit this, right, to the database. So connection.commit, and this should actually go ahead and insert into database. Okay. Just verifying that everything is fine. Insert into clients, location, MAC, SSID, values. That should pretty much be it. So now we can do a client-db.py mon0. Let's say we go to 2000 packets. Name of the file is going to be probes.db. That's what we gave the name, if you recall in here. And finally, the location, let's say, is going to be office, right? Now let me go ahead and try to search for stuff. Here goes, searched for a bunch of stuff in here, right? New stuff is getting added. Fantastic. let me go ahead, kill this, open up the database and do a select star from clients. Fantastic, right? In this case, of course, if you notice, we are not checking for duplicate entries and stuff like that. So there seems to be a lot of re-entries happening. Right? So the exact place at which we would go ahead and put this in would decide whether we can eliminate duplicates and all of that. But I leave that as an exercise to you, right? You can go ahead and eliminate duplicate entries, because every time you restart, you're going to also find a lot of this happening. Right? And you could go ahead and put that in here accordingly. So in this case, we are going ahead and putting this in at this location, which probably isn't the best place to do it because we are recreating the client table again and again. So I could just remove this from here and put it in here. Go ahead and delete from the database as well. So we have SQLite 3 probes.db. We can just do a delete from clients. So now if you do a select star from clients, actually see nothing exists in there. Now we can go back, rerun our program. We could start searching. We found a bunch of places, right around 49 of them. Hit a Control C, go back, select star from clients, and there you go, right? Beautifully laid out. Now we can go ahead and do different searches and whatnot on this database, right? Fantastic. Now, if you recall, we deleted from the database, but of course, the ID keeps auto incrementing. That's the reason why we got the next one. It pretty much won't start from 1 unless we drop the table entirely and recreate it. But now you can already see the power of what we have here, right? So now you could actually run queries. So as an example, if I'm interested in specific MAC, I could run a query saying select star from clients where MAC ADDR equals, paste this MAC, right? My mistake. MAC ADDR, and there you go, right? Now let's say you are looking for and, right, where location equals airport, just in case this MAC ever appeared at the airport, and of course you would end up getting a false here, right? So this is how, once you start collecting a lot of information from various locations of where you do the pen test, you might be able to correlate different clients, access points, and all that. Now, in the next video, we will look at how to probably use more detailed information from other tools and push them into the database so that we can work with them. Anyway, I hope you enjoyed this video. And if you're having fun at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Welcome to the Scripting Wi-Fi Pentesting Tools in Python series at Pentester Academy. Now in this video, we will look at how to take aerodump-ng's output and put it into a database so that we can search and play with it. So what are we really going to do here? Well, aerodump-ng has an option where we can go ahead and store its output in the form of a net.xml file. Now this XML file is something we can go ahead, feed into an XML parser like Beautiful Soup, and then mine and push useful information into the SQLite database. So let's jump right in. Now the first step is to make aerodump-ng create the net.xml. Now this can be done very easily with the -- write option, and let's say we call the file Pentester Academy. This is what the file name would be prepended with. Let's give it a couple of seconds so that it can go ahead and mine some information from here. Couple of more seconds, probably I'll just allow it to run for a minute. That ensures that we have a very good XML file with lot of networks in there. And you can see this classic issue where things end up just scrolling down from the visible screen, and there could be a ton of networks, right? So we see a lot of hidden SSID networks. Okay, let me kill this. Now if I actually do a ls for all files prepended with Pentester Academy, you would actually find a bunch of them. The one we are interested in is the Pentester Academy -01 kismet.net.xml, right? There we go. So if you notice inside this, the different wireless networks are mentioned. Right. And you can clearly see that there are both wireless networks as well as clients as well, right? Now I'm going to show you with the wireless networks. The client part is something you can try later on. So let's actually look at what this file contains, right? Let me just do a cat and let me do a grep on wireless network. So if you notice, we have a bunch of these networks, I think 20 to be exact, right? We could even check for the ESSID fields. We can see a bunch of them in there. Cool. So now let's begin writing a Python script for this. Now just for our reference, I'm going to open up the net.xml file in another terminal. Now if you notice, we actually have each individual network beginning with a tag wireless network, and inside that we have an SSID tag which contains the SSID, the encryption. We also have a BSSID tag, and then we have channel and a bunch of other things. So in this video, we will take up each of these networks, figure out the ESSID, figure out the encryption, the BSSID, the channel, and then put all of this into the database. So let's first create our database. Just like in the last video, SQLite, let's call this database networks.db. I'm going to create a table, create table, let's call this networks as well. first field, let it actually be an ID field, just like what we had done before, and we would like this to auto increment. So ID integer. Let's also make this the unique primary key, auto increment. Then let's put in a location parameter which the attacker can add. Location share 100. Of course, this cannot be null, so not null. Then we have the ESSID share 255, not null. Then we have the MAC address. Okay, this can be a share 50, not null. Then we have the channel, it can just be an int. What else did we plan to put in? Channel BSSID, the encryption, right? Can share 200, not null. There we go. So we have created the table in the SQLite file. Now let's go back in here and start writing some code. So let's call this arrow dump to SQLite.py. Let's import SQLite 3 sys. And if you recall, I said the XML parser I'm going to use is Beautiful Soup, which can do both HTML and XML parsing. From Beautiful Soup, import Beautiful Soup. Right now, let's actually do this manually first to ensure we understand what is happening. So file to open is going to be this one, Pentester Academy -01.kismet.net XML for reading. Let's display the file. There it is. Now let's import Beautiful Soup. So let's create quick XML Beautiful Soup representation. Beautiful Soup file. Fantastic. Now, Beautiful Soup actually allows us to search for different, parameters very simply. So let me show you how. Now, let's say you wanted to isolate the list of all wireless networks. All I would have to do is networks equals XML DOM.find all wireless network. And if you look at the len networks, actually find this to be 20. And now we actually have each of these networks in here, if you notice, right? From pretty much start to finish. Here it is. Right, fantastic. Now the next thing I really want to find in here is the ESSID. Now the best part is there is only one ESSID field in there. So I could actually do for network in networks print network.find ESSID. Right, and then I can do a print ESSID. Oops. My mistake. For network, blah blah blah. I just have to print this. I'm not storing that in a variable anywhere. And there you go. So if you notice, we get the list of all the ESSID tags, right? Now, if we were interested only in the actual value, we could simply do this dot text. And there you go. Now we actually have a list of all the ESSIDs, right? The blank ones are really hidden SSID networks which have nothing in there. You can see there are a couple of them. Fantastic. Now what else do we have here? Similarly, we can actually go ahead and find encryption, the BSSID as well as the channel, right? So just do this for the encryption just to show you an example. There you go, right? So now let's actually incorporate this in our Python script. So file equals, rather let me do a quick shortcut. We'll take the file name as input so that we can keep using this tool with more than one XML files without having to change it every single time. There you go. For network in XML DOM dot find all wireless network, right? This is the tag name, as we can clearly see here, wireless network. Now inside this, let's first get the ESSID, which would be network.find ESSID.text. Similarly, channel, just copy these out. Channel, similarly BSSID, and then encryption. Then finally, encryption. We saw a couple of hidden SSIDs, so we can have an additional line which says if not ESSID, ESSID equals hidden ESSID, just so that it looks good in the database. Now I can very simply do a print ESSID channel BSSID and encryption. Let's see what happens. Chmod 8+X. There you go. Right, we have the hidden SSID, the channel, the BSSID, and the actual encryption. Fantastic. Might be interesting just to go ahead and number this up. Makes it more readable. And there we go, right? Looks way more beautiful right now. Now the next step is pushing this into the database based on the schema which we have created in here, right? Remember, we have an extra location tag which we might need to take in as input. So let me do that. Let me actually add a little location here, which is sys.argv 2. Now let's write the database code. Connection equals SQLite3 dot connect. Let's actually take this as input, sys.argv2. Actually make this argv2 and we can make the location argv3, right? More logical that way. And of course at the very end here, connection dot close, so that we gracefully finish it. And here is where we go ahead and add our insertion code. So connection dot execute, insert into networks, location, ESSID, MAC ADDR. What else do we have in here? Channel encryption. Values, there seem to be 5 of them. Question, 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 question. Then let's actually put in the values. Location, and then we have ESSID, which is pretty much the same in here. MAC address would be the BSSID. Channel, we have encryption. Seems okay. So this is the first one. The second one is really the name of the SQLite database which you created, which is networks.db. And the third one is the location, let's say home office. There you go. Looks perfectly okay right now. Figure it out in just a bit. Select star from networks. Here is our huge mistake. We forgot to commit it. Right? Remember that after going ahead and executing this, you can actually commit per entry or you can commit in a batch. I'm just going to commit each of them. Right? You could even commit after you exit the loop once for every single thing. There we go. And there you go. Fantastic. Right. So now you can run really interesting queries on all of this. So for example, if you were interested in all access points, which might be in channel 11, you could actually do a select star from networks where channel equals 11. There you go. You have both of these. Right? Now there are a ton of other parameters depending on what you're doing could be interesting to you, and that's something I would go ahead and have you explore. You can have as elaborate a database schema as you desire, right? Depending on what you would like to store in there. Now the advantage I've seen from a pen tester's perspective is that this really allows you to retain the data well, to allow you to search better, and actually you can even dump it in different formats and import it into different reporting tools and whatnot. So I would highly recommend going and creating such a schema for yourself so that you can analyze networks better. Okay, so hope you guys enjoyed this video, and if you have, please do recommend Pentester Academy to your friends and colleagues in the InfoSec community. Thank you. Hello all, welcome to the Scripting Wi-Fi Pentesting Tools in Python series at Pentester Academy. Now in this video, I'll show you how to code up a deauthentication tool using scapy. Now going back to the wireless security 101, a deauthentication packet, or deauth as it's popularly called, goes ahead and disconnects a client AP pair. Now, deauth packets can be broadcast, which is typically when the access point sends it to all connected clients and tells them to basically deauthenticate and maybe reconnect. Uh, or unicast, which is either sent from a client to a AP or an AP to a client. Now, the aftermath of a deauth attack is pretty much instant disconnection. It is almost always used as a DOS attack and is a very potent attack in the sense that you'd pretty much not have clients being able to connect to an access point while a deauth attack is ongoing. So you might have used tools like airreplay-ng to go ahead and conduct a deauth attack. In this video, let's look at how to write a deauth attack tool in just 4 or 5 lines of scapy. So let's jump right in. So I'm going to call this the deauthentication.py tool. Let's go ahead import sys so that we can take command line arguments. Then we'll do an import, or rather from scapy.all import star. Now, if we were to monitor our access point, let's say the one I've set up on channel 11, right, called totally secure. This is the one which I've set up. I'm connected to right now as well, and I can ping Google right from my access point. Right, let the pinging continue. Now I would probably feed the MAC address of the AP as an input, and in this version of the deauth tool, I'm going to create a broadcast deauthentication packet. The unicast one is pretty much on exactly the same lines, and I leave it as an exercise to you. Now, a broadcast deauth packet is sent from the access point to the broadcast address, which means address 1 or the destination MAC would be all Fs. The sender MAC would be the access point's MAC, and of course the BSS ID would also be the AP's MAC. So with this, let's go ahead and build the tool. So let's define a variable called the broadcast MAC or BRD MAC. Let me fill that in with all Fs. 1, 2, 3, 4, 5, 6. Yeah. Now let me create our packet. We have the radio tap header first. Nothing needs to be modified in here, of course. Then we have the .11 header, and all I really care about in this are the addresses. So ADDR1, the destination MAC would be BRD MAC. ADDR2 would be sys.argv1, which is the AP MAC which we will enter as input, and ADDR3 would also be sys.argv1, right? Then it tells scapy that this is a .11 deauth packet. Now once you do this, scapy automatically would fill up the type, subtype, and all of that for you. Now after this, we need to send this packet. We want to send it on layer 2, so we use send p packet, and then after that you have the interface on which you want to send this. I'm on 0, I'm hard coding it. Then the number of packets to send, let's say a pretty large number, and then the interpacket time, and there we go. And that's all is required to program a broadcast deauthentication attack tool using scapy. So let's actually do a quick demo. We need the MAC address of the AP. That's the AP we are currently connected to, totally secure. Paste it, and before I run, we'll keep monitoring. The pings seem to be working fine. Started the deauth attack, and if you notice, the ping has stopped. Now, Mac or many operating systems actually do not show a disconnection immediately. Uh, but right now you're already seeing it's trying to reconnect, right? So if we stop the attack, go back in here, right? My Mac is trying to reconnect. It's established a connection, and again, the ping packets go through comfortably. We start the deauth attack again, and there you go. We disconnect the client. Now, keep in mind, broadcast deauths are pretty powerful. In a hotspot environment, you could pretty much have most clients getting disconnected, and this could cause loss of communication because of the DOS attack, right? And right now, you're almost seeing how incredibly powerful scapy is, that it pretty much allowed us to create a deauthentication attack tool in less than 10 lines, right? Fantastic. So hope you guys enjoyed this video. Try out the deauthentication tool, and if you're enjoying your time at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all. Welcome to the Scripting Wi-Fi Pentesting Tools in Python series at Pentester Academy. Now in this video, we will look at how to create fake AP beacons using scapy. Now, when can this come in handy? Well, the ability to create AP beacons can be used in a ton of ways. Eventually, you can use this to create a full-blown fake AP like Airbase NG, right? This would be one of the small components in there. You could also go ahead and escalate this to full-blown beacon frame fuzzing, as we've seen with tools like MDK3 in the Wi-Fi security course, and really a ton of things. So what is the end objective of this video? Now we would like to create an access point by sending out just beacons, and we would need to go ahead and confuse Wi-Fi devices around that this is an actual AP and they should display it in their network lists. So let's jump right in. I'm going to call this fake beacons ap.py. Let's import sys. Now the first step, of course, is to create the packet. Before that, let me go ahead and define the broadcast ADD address. The BSSID of the AP, all is, and now let's actually create the packet. First is the .11 header. In that, address 1 or destination would be broadcast. Address 2 would be the MAC of the AP, and address 3, the BSSID, would again be the MAC of the AP. Then we have the .11 beacon layer. Now for this we would need to define the capabilities of the AP. So let's actually open up Wireshark and inspect a real beacon frame from an access point, which we've set up called totally secure. Here it is. Let's try and replicate aspects of the beacon frame. So I have selected totally secure, and if I go to the beacon frame in here, let's go right down to the fixed parameters. If you notice capability information, which tells any receiving device that this is an AP, etc., is actually in here. Now we'll clone this value 0411. If you look at the hex equivalent in here, remember to account for the EDNness, and hence the value which would be sent is 1104, right? So go in here and say capability information 0x1104, right? 1104. Now after that we have a bunch of tagged parameters. For an access point, the SSID, supported rates, DS parameter, and the TIM is something which is very, very important, right? So let's go ahead, put these four in. The SSID parameter. Now all of this, if you recall in previous videos, are nothing but .11 ELTs. So let's go back in here and let's put in our first .11 ELT. Now the ID field is going to be 0 for the SSID. The info field would be the SSID, which is sys.argv1. Let's take that as input. So this is the first .11 ELT. Let's create the next one. In this case, the ID field is going to be for the supported rates, right? The value of the ID field is 1. Let's go back in here, and the info looks like this AP is going ahead and giving out 8 different rates. So 82, 84, so let's just copy this 82, 84, 8B, 82, 84, 8B, and then 96, 24, 30. 96, 24, 30, and then 96, 24, 30, 48, 6C. Great. Let's actually put in the next one. This is going to be the DS parameter. The tag number is 3 and the value, let's say, is 11. Tag number is 3. The value just depends what we want to put in here. Let's say we put in the exact same value as this AP, 11, which would be 0B. Then you have the final ELT, which is the DTIM, which is important. This has a tag number 5. Let's put that in. ID equals 5, info is equal to. We go back in here. 0001, 0000. These seem to be the 4 values, right? 0001, 0000. Let's just put them in here. And there we go. Now let's send this over layer 2. I want to send the packet. The interface is going to be mon0 count. Let's take that as input. Sys.rv2. Then the inter packet time, let's say 0.2. There we go. Okay, so let's try this out. So first step is the SSID. Let's see, hacker rig. And the second input was the number of packets. Let's put in a large value. Now let's see if hacker rig shows up. And there you go. If you see, hacker rig is now showing up on our wireless devices. Fantastic, right? So this is how, in just again of just probably how many lines is this? hardly 10 lines of scapy, probably less if you remove all the blank lines. We've created uh, a fake access point using beacon frames, right? And you clearly see, once you understand the whole layered approach in scapy, how easy it is to actually go ahead and build and replicate existing security and pen testing tools. Awesome. So hopefully you guys had fun in this video, and if you have, please do recommend us to your friends and colleagues in the InfoSec community. Thank you.